It is already mentioned that there are numerous advantages for negative feedback amplifier like gain stability, improvement in frequency response, reduction in nonlinear distortion, increased circuit stability, reduction in noise, increase in input impedance and decrease in the output impedance, which compensates its only drawback of reduced gain. Now let's discuss about these advantages in detail. The first one is the gain stability. That is, negative feedback introduce stabilization in the gain. To explain how a negative feedback amplifier introduces better stability in gain, let's consider the voltage gain of the amplifier with feedback, that is AVF is equal to AV divided by 1 plus MV AV. It is the voltage gain of the amplifier with feedback is otherwise called the closed loop gain, and AV is the open loop gain and MV is the feedback fraction. For negative voltage feedback in an amplifier to be effective, the designer deliberately makes the product MV-AV much greater than unity. So if we make this assumption, that is, the designer makes this condition MV-AV is much greater than 1 by making the open loop gain as very large, then the quantity 1 plus MV-AV can be approximated to MV-AV. So when we substitute it here, we will obtain the closed loop gain is equal to 1 by MV, that is the reciprocal of the feedback fraction, which means that gain depends only on the feedback fraction. That is, the gain of a negative feedback amplifier depends on the characteristics of the feedback circuit only. As feedback circuit usually consists of a voltage divider formed by the resistors, therefore it is unaffected by the changes in temperature, variations in the transistor parameters and frequency of the input signal. Hence the gain of the amplifier is extremely stable. Therefore we can say that an important advantage of negative voltage feedback is that the resultant gain of the amplifier can be made independent of transistor parameters or the temperature variations or the supply voltage variations. Now don't think that it is necessary to have very large open loop gain for achieving gain stability in negative voltage feedback. If we calculate the percentage change in gain with feedback and without feedback, we can see some improvement in the gain stability even if the open loop gain AV is not very large. So to substantiate this statement, let's calculate the percentage change in feedback with feedback and without feedback. The percentage change in with feedback is given by, if AVF is the closed loop gain or the gain of the amplifier with feedback, then percentage change is DAVF divided by dVAF divided by A will give us the percentage change in gain with feedback. And if AV is the open loop gain or the gain of the transistor amplifier without feedback, then DAV, the differential or change in the voltage gain with respect to the voltage gain, DAV by AV will give the percentage change in gain without feedback. So now let's calculate these two quantities. To calculate this quantity, let's consider the expression for the gain with feedback in terms of the gain without feedback, that is AVF is equal to AV divided by 1 plus MV into AV. Now differentiate this expression with respect to AV, then it will be dAVF divided by dAV is equal to 1 divided by, use the product rule, AV as the first term, the differential of first one is 1 itself into 1 by MVAV plus the differential of first term into differential of second, it is minus 1 by 1 plus MVAV all square into MV. So this is equal to, if we take the 1 plus MVAV all square as the LCM, then it is 1 plus MVAV minus MVAV divided by 1 plus MVAV all square. So this is equal to, this minus and plus MVAV will cancel, but remains is 1 divided by 1 plus MVAV all square. Now if we divide these two equations or rearrange this equation this way, dAVF is equal to dAV divided by 1 plus MVAV whole square. Let it be equation number 1 and this is equation number 2. Now if we divide equation number 2 by 1, which will give the LHS will be dAVF divided by AVF, which is the percentage change in gain with feedback, and the second one will be dAV divided by 1 plus MVAV all square divided by AV divided by 1 plus MVAV will be into 1 plus MVAV divided by AV. So this one and 1 plus MVAV in the numerator and 1 term in denominator will cancel, but remains is 1 divided by 1 plus MVAV into dAV divided by AV. So by looking into this equation, we can see that this LHS is the dAV by dAVF, that is the percentage change in gain with feedback, and the RHS will be 1 by 1 plus MVAV into the dAV by AV is the percentage change in gain without feedback. Now we know that the quantity 1 plus MVAV is always greater than 1 or much greater than 1. If it is so, then 1 divided by 1 plus MVAV will be less than 1. So we can say that this percentage gain or percentage change in gain with feedback is less than percentage change in gain without feedback. So we can say that even if open loop gain AV is not very large, some improvement in gain stability can be achieved. So this is the first advantage of using a negative feedback in the case of an amplifier. Now let's consider the second advantage, which is the improvement in frequency response or reduction in frequency distortion. Since we know that the open loop gain can be expressed in terms of the closed loop gain, or closed loop gain can be expressed in terms of the open loop gain, and if the open loop gain is very large, we have obtained the expression for closed loop gain, or the gain of the amplifier with feedback as 1 by MV, that is MV is the feedback fraction. It follows from this that if the feedback network is purely resistive, the gain with feedback becomes independent of signal frequency, even though the basic amplifier is frequency dependent. The result is that the gain of a negative voltage feedback amplifier is substantially constant over a wide range of signal frequency. That is, the frequency distortion arising because of varying amplifier gain with frequency is considerably reduced. So we can say that a negative feedback improves the frequency response of the amplifier. Now let's discuss about the another advantage of using negative feedback, which is the reduced nonlinear distortion. When a transistor or other device is driven beyond its range of linear operation, harmonic distortions occurs. That is, at large signal voltages, the voltage gain changes at various points in the cycle. So now let's see how this negative feedback reduces the nonlinear distortion. For that, let's consider an amplifier with open loop gain AV which produces a distortion D in the output signal without feedback. Now when feedback is applied, we know that the output as well as the distortion is fed back into the input. Let gain with the feedback is AVF and the distortion in the output is DF. A part of this DF, if MV is the feedback fraction, then MVDF will be the distortion fed back to the input. It gets amplified by a factor AV and becomes MVAV into DF. So again, if DF is the distortion and if feedback fraction is MV, then this DF will be fed back to the input by the feedback circuit of with a factor of MV, that is MV into DF will be the distortion fed back by the feedback circuit to the input of the amplifier. The amplifier has a gain of AV, So this distortion will be amplified as AV into MV DF in the amplifier output. So the net distortion will be original distortion is net distortion DF will be equal to the distortion D minus MV into DF. So now take this to the LHS, then it will be DF plus MV into DF is equal to D, or DF is equal to D divided by 1 plus MV. Again we know that the quantity 1 plus MV is greater than 1, so here we can say that this DF is always less than D. Thus, by applying a negative feedback to an amplifier, the distortion is reduced by a factor of 1 plus MV. However, it is to be noted that improvement in distortion is possible only when the distortion is introduced by the amplifier itself, not when distortion is already present in the input signal. So this thing tells us that the negative feedback amplifier reduces the nonlinear distortion only when this distortion is produced by the amplifier circuit itself. If there is a nonlinear distortion in the input signal itself, it cannot be reduced by the feedback circuit. And this is another important advantage of using a negative feedback. That is, by applying a negative feedback to an amplifier, the distortion is reduced by a factor of 1 plus MV. Now the other advantages we can discuss in the next lecture. Thank you.